Hello, Matthews Gatos here. Welcome to fraction exponents and radicals. Let's get started. So I want to do this investigation on your calculator. I want to take 4, 9, and 16, raise it to an exponent of a half, just to see what does that half exponent actually mean. So let's go to your calculators, and I'm going to do 4 to the 1/2. Your power key, your exponent key, is right above your division. So 9 to the 1/2, and I'll do 16 to the 1/2. So it looks for all of these, I'm getting a whole number answer. So let's record these here. 4 to the 1/2 is 2. 9 to the 1/2 was 3, and 16 to the 1/2 is 4. So I want to know, how can I relate 4 to 2 in the same way I relate 9 to 3 and 16 to 4? Well, each one of those I notice is a square root. Square root of 4 is 2, square root of 9 is 3, and the square root of 16 is 4. So it looks like when I raise it to a fraction exponent where my denominator is 2, I'm taking the second root. We don't really write it there, but that's what it means. When there's no index there, it's an imaginary 2, which means square root. So I think x to the 1/2 in general means square root of x. Let's try another one, this time with 1/3 as my exponent. So 8, 27, and 64 to the 1/3. So I'm going to do 8 to the exponent of 1/3. And then I'll do 27 to the exponent of 1/3. And last but not least, 64 to the exponent of 1/3. And I get, again, 2, 3, and 4. So again, back to my notes here. I want to know, is there a way I can relate 8 to 2 in the same way I relate 27 to 3 and 64 to 4? So all of those look like cube roots. So the cube root of 8 is 2, the cube root of 27 is 4, and the cube root of 64 is 4. So it looks like x to the 1/3 when the denominator is 3 in general just means the cube root of x. So let's put this together. If x to the 1/2 means square root, x to the 1/3 means cube root, x to the 1 over n is the nth root. Or in radical form, x to the 1 over 9 is nth root of x, where n is the index. Let's try some examples. So if I have 625 to the 1/2, the denominator of 2 tells me I'm taking the square root of 625, which I know is 25. Now I know that because 25 times 25 is 625, and the square root is one of two identical factors. Let's try another one. 1,000 to the 1/3. The denominator of 3 tells me I'm taking the third, or cube root. The cube root of 1,000 is just 10. Now I know that because 10 times 10 times 10 is 1,000, and the cube root of 1,000 is one of three identical factors, which is just the 10. Now, if I know how to evaluate fraction exponents where the numerator is 1, how can I evaluate a fraction exponent where the numerator is not 1? Well, to answer that question, I'm going to borrow from what we did last year. So last year we did questions like this. 3 squared to the exponent of 4. Now, 3 squared really means 3 times 3. Now, if I raise 3 times 3 to the exponent of 4, that means take my base, multiply by itself 4 times. So I have a bunch of repeated factors of 3. In fact, there are 8 of them. So my final answer would be 3 exponent 8. Now, what I want to know is, how can I go from this directly to this? So I can see that my base of 3 stays the same, but what did I do the 2 and 4 to end up with an 8? Well, hopefully you can see that 3 squared to the exponent of 4 is the same as 3 to the 2 times 4, which is 3 to the exponent of 8. Now, in general, this is called the power rule. So x to the exponent of m raised to the exponent of n is x to the m times n. but we don't really need to write our multiplication in between there. Here's a better way of writing it. I'm going to write it as x to the m to the exponent of n is x to the m times n. So what I'm thinking is I'm going to borrow the power rule and combine that with fraction exponents where the numerator is 1 to come up with how to do any fraction exponent. So let's try this. So 25 to the exponent of 3 halves. So I'm going to rewrite 3 halves as 1 half, which I know is square root, times by 3. So 1 half times 3 gives me 3 halves. So I'm going to rewrite this as 25 to the 1 half raised to the 3. So 25 to the 1 half, I know since the denominator is 2, it means square root, and I raise that to the 3. Well, the square root of 25 is 5, and 5 cubed is 5 times 5 times 5, which is 125. So if my method works, let's check it on the calculator. 25 to the 3 halves should be 125. Let's check. So 25 to the 3 halves. 3 divided by 2 is in fact 125. I did it correctly. So let's try another one using this same method. Negative 27 to the 4/3. Okay, so again, I know that I can write 4/3 as 1/3 times by 4. So negative 27 to the 1/3, and I'm going to raise that to the exponent of 4. So I'm actually going to shift around my brackets. I'm going to do this. So negative 27 to the 1/3, and then I'm going to raise that to the exponent of 4. Well, anything to the 1/3 where the denominator is a 3, I know I'm taking the cube root. So that's like the cube root of negative 27, and I'm raising it to the exponent of 4. So the cube root of negative 27 is negative 3, because negative 3 times negative 3 times negative 3 is negative 27. And I'm going to raise that to the exponent of 4. So that's negative 3 times negative 3 times negative 3 times negative 3, which is positive 81. Let's check this one on the calculator. So negative 27 to the 4/3. So let's put the negative 27 in brackets. And then I'm going to raise that to the exponent of 4/3. So 4 divided by 3. And I get 81. So it looks like my method works. Now, you can continue to use this method, or I have a shortcut for you. So this shortcut is tie bow. Now, I don't know if any of you know, but there was actually a whole line of exercise videos called tie bow, and that's not what I'm talking about. This is what I'm talking about. T stands for top. So my top, or my numerator of my fraction, is going to go inside, and B stands for bottom, denominator. The bottom of my fraction exponent goes on the outside. So what you really need to know here is that the bottom number is the root, and the top number is the exponent or the power. That's how the fraction exponents relate to one another. So let's try this with the shortcut. So top 3 stands for inside, so it's 16 cubed, and then 4 on the bottom stands for the root. Now, I could evaluate that, but I don't know about you. I don't know what 16 cubed is off the top of my head. So another way that I can write that is this. 4 still goes on the outside, but instead of writing it as a 3 cubed there, I can write it as a 3 cubed there. Now that's a little easier for me because I know what the 4th root of 16 is. The 4th root of 16 is 2, because 2 times 2 times 2 times 2 gives me 16. And I'm going to take that 2 and I'm going to cube it, which is 2 times 2 times 2, which is 8. So let's see if my little shortcut works. Is 16 to the 3/4 equal to 8? So go over here and we'll try. So 16 to the exponent of 3 divided by 4, and I get, yes, 8. So I know that it works. So that shortcut is something that you are free to use as well. So I wanted to end this lesson by telling you a joke about rational exponents, but only a fraction of you would get it. Get it? Rational fraction, only a portion of you. If you like this video, I ask you to please give it a thumbs up and hit subscribe. It helps me reach more mathies in need of help. Thanks for watching, and see you for the next one.